Hello everyone, through this video we are going to discuss the important questions of exercise 11.3. Here goes question number 1. What is given here? In each of the following cases, determine the direction cosines of the normal to the plane and distance from the origin. So here there are 4 similar questions given under question number 1. I am going to proceed with one of these 4 sums, and I am picking up 3. I'm in the third one, that is C. So what is given here? Let us proceed with the solution. It is given that the plane, the equation of the plane is twice x plus thrice y minus z is equal to 5. Now actually this in case of this equation we can consider this as ax plus by plus cz is equal to d. This could be the form. Now say d1. So converting this, actually when we try to find out the direction cosines of the normal to this plane and the distance from the origin, in that case what do we have to do? Both the sides should be divided by the square root of the sum of the squares of coefficients of x, y and z. Okay, so here we are going to do that, dividing both the sides, let's mark this as 1, dividing both the sides of 1 by square root of 2 square plus 3 square plus minus 1 whole square. So what could be the result? Its result is root 4 plus 9, it is 13 plus 1, it is 14. So in 1 implies we shall get what? Twice x plus thrice y minus z divided by root 14, that is equal to 5 by root 14. This will imply 2 by root 14 x plus 3 by root 14 y minus 1 by root 14 z is equal to 5 by root 14. So actually whatever form I got just now, this is actually getting converted to the direction cosines. This is the first direction cosine, we can consider this to be L. This is the second direction cosine M, and this is the third one, this is N. And the distance, actually what is asked here, distance from the origin, its distance from the origin is this one. So we can write what? Hence the direction cosines of the normal to the plane. Hence the direction cosines of the normal to the plane are, what could this be? 2 by root 14, then 3 by root 14 and minus 1 by root 14, and the required distance from origin is equal to 5 by root 14. So this is the answer. So using similar method, the remaining sums of this number can be found out. Similarly, question number 2. In question number 2, same thing is given, similar type of question. So I am proceeding to question number 3. In question number 3, what is given? Find the Cartesian equation. Find the Cartesian equation of the following planes. So amongst this I am taking one. Three sums are given. So amongst this I am taking the third one, that is C. Here in this case, given plane is R, vector R dot S minus twice T I cap plus 3 minus T J cap plus twice S plus T K cap bracket closed is equal to 15. Now here in this case we have to consider any arbitrary point. Say for this vector R, we shall consider any arbitrary point x comma y comma z whose position vector could be vector R. So what could be written here? Starting with the solution part, solution goes here. We know that for any arbitrary point, capital P, say x comma y comma z, R, vector R will be equal to x I cap. Actually this is a point considered on the plane. Okay, on the plane vector R will be equal to x I cap plus y j cap plus z k cap. So this value, if I substitute here in this expression, in the main expression given, so that will be getting converted into the Cartesian equation. Now vector R dot, what is given here in the question, this equation only we are writing once again here, twice T I cap plus 3 minus T J cap plus twice S plus T K cap, that is equal to 15. So in place of R I am going to put I cap, x I cap plus y j cap plus z k cap dot s minus twice T I cap plus 3 minus T j cap plus twice s plus T k cap, that is equal to 15. After this what we shall get, after finding out the dot product, twice T x, it will be plus 3 minus T y plus twice s plus T z, that is equal to 15. So this is the required, which is the required Cartesian equation, So this is the answer for this part. Next I shall come to question number 5. In question number 5, what do we get? Actually both the questions are important here. Question number 5 is what? Find the vector and Cartesian equations. Find the vector and Cartesian equations of the planes first one is given to be that passes through the point 1 comma 0 comma minus 2 and the normal to the plane is I cap plus j cap. Actually this should be minus k cap. What do we have to find out here? Find the vector and Cartesian equations of the planes that passes through the point. Actually this should be plane. that passes through the point 1 0 minus 2, and the normal to the plane is this one. So here in this case, while doing the solution, what do we have to do? The equation of the plane that will be normal to the plane, this is the plane to which it should be normal. We can write here in the solution part, equation of a plane such that the normal to the plane is, actually by formula we get it, vector r dot I cap plus j cap minus k cap plus d is equal to 0. Again it is given that the plane passes through the point, this one, 1 0 minus 2. So its position vector we have to write down. Again, let's mark this as 1. Again, the plane passes through 1 0 minus 2 with a position vector. What is the position vector here? I cap, 0 j cap will be meaningless, so minus 2 k cap. Okay, so this actually in place of r we can substitute it, because at some point, means at this particular point, the position vector for r will be this one. Therefore 1 implies, in place of r I shall be putting it now 2 k cap dot I cap plus j cap minus k cap plus d is equal to 0. Let's find out its dot product. So it is 1, then after plus 0, then after plus 2 plus d is equal to 0. So I shall get here d is equal to minus 3. So in the main vector, means in 1, we can put this result. Therefore 1 implies vector r dot I cap plus j cap minus k cap. In place of d I can put 3. Yes or no? That is equal to 0, which is the required vector form. Which is the required vector form. Again, for Cartesian form, what do we have to do? Again, for Cartesian form, we can write what? Vector r dot I cap plus j cap minus k cap is equal to, minus 3 equals to 0. This will imply x I cap plus y j cap plus z k cap for any arbitrary point x comma y comma z. We are considering this dot I cap plus j cap minus 3 minus it should be k cap minus 3 is equal to 0. After this, what can I write? After finding out the dot product, x plus y minus z it should be, then minus 3 is equal to 0. So this is the required Cartesian equation. So after that, coming to the other part of the question, same question, number 5, the second part we are going to do now. Question number 5, the second sum. What is given? We have to find out vector and Cartesian equations of the planes that passes through the point that passes through the point 1, 4, 6 and the normal to the vector normal to the vector, there is a correction here. Normal vector, I should write here normal vector to the plane is I cap minus 2j cap plus k cap. So coming to the solution part, here in this case, what do I have? The position vector of the point 1, 4, 6 is what? I cap plus 4j cap plus 6k cap. Okay, again in this case, actually the normal vector to the plane is given. Let the normal vector to the plane be vector n such that what do I get here? Vector n is equal to I cap, it is already mentioned in the question, the second vector, okay, 2j cap plus k cap. So the vector equation of the plane can be given in this way. This is again in accordance with formula. So the vector equation of the plane can be written as, this is the way of writing, vector r minus the first vector, position vector, this one will have to be subtracted from it, 4j cap plus 6k cap, right? This should be written within bracket, then after dot vector n should be written, that is equal to 0. So after this I shall write what? Vector r minus I cap plus 4j cap plus 6k cap dot, in place of vector n we can write what? I cap minus 2j cap plus k cap, that is equal to 0. So this is the required vector equation. Then after we shall come to the Cartesian equation, and for Cartesian equation of course we have to consider an arbitrary point, say x, y, z lying on the plane, for which vector r could be I cap plus x I cap plus y j cap plus z k cap. Here we shall get, for vector equation we consider an arbitrary point, capital P within bracket x, y, z in the plane such that vector r is equal to x I cap plus y j cap plus z k cap. So this value, actually this value of r, I am going to put here in this equation. So let us check what we get. Let's mark this as 1. Therefore 1 implies, in place of r I shall be putting x I cap plus y j cap plus z k cap minus I cap plus 4 j cap plus 6 k cap dot I cap minus 2 j cap plus k cap is equal to 0. So we shall be getting here x minus 1 I cap plus y minus 4 j cap plus z minus 6 k cap dot I cap minus 2 j cap plus k cap is equal to 0. So after this what shall I get? This will be x, after finding out the dot product, x minus 1 plus not plus, it should be minus, it is minus because minus 2 is here, minus 2 into y minus 4, then after plus z minus 6 is equal to 0. So what could be written? X minus 2y plus z, then minus 1 plus 8 minus 6 is equal to 0. So this will be ultimately x minus twice y plus z minus 1 plus 1 is equal to 0. So this is the required Cartesian equation, which is the required Cartesian equation. So this is how this number could be solved. Next, coming to question number 6. So in question number 6, what is given? Find the equation of the planes. Find the equation of the plane that passes through the following points. Following 3 points actually. So here also 2 parts are there. I'm solving the first part. Here points given are 1 comma 1 comma minus 1. Then after I get here 6 comma 4 comma minus 5, and then after minus 4 minus 2, then 3. So coming to the solution part, directly formula could be used here. The given points, first we have to check its collinearity, whether these are collinear or not. If this determinant value means, first of all we are going to consider these 3 points as A, B and C. Let the given points be, capital A 1 comma 1 comma minus 1, capital B 6 comma 4 comma minus 5, and capital C minus 4 comma minus 2, 3. Now arranging in determinant form, these points, when we arrange in determinant form, let us check what result we get. Minus 2, 3. So coming to the result, we shall be getting 12 minus 10. 12 minus 10, then after minus 18, yes, here it is 18 minus 20, then minus 12 plus 16. Let us check what result we get. 2, then minus plus, it will be 2, then after minus 4. So ultimately result is 0. Since this value is 0, therefore there will be infinite number of planes will passing through these 3 points, and these 3 points will be collinear points. So we shall write here hence A, B, C are collinear points, and hence there will be infinite number of planes passing through these points. So this is the answer of the first part of this question. Similarly, coming to the second part, again we have to check collinearity. Here the points are for B. The points are 1 comma 1 comma 0, then after we shall be getting 1 comma 2 comma 1, and then after minus 2 2, then minus 1. So first we shall be checking the collinearity. Let these points be, let these points be capital A 1 comma 1 comma 0, then capital B 1 2 1, and capital C -2 2 -1. So now 1 1 0, then 1 2 1, then -2 2 -1. While finding out the determinant value, the values will be coming like this: -2, then -2, then after we shall get minus, then -1 plus 2. These will be -4 -1. So the answer comes as -5, which is not equal to 0. Since A, B, C are not collinear, therefore the required equation of the plane, the required equation of the plane is, this will be taking this form. We already know the formula. X minus, along the first row in determinant form only, we have to calculate this. This is x minus x1. x1 is what? 1 here. Then y minus 1. Then after z minus 0. So x2 minus x1, second row will be x2 minus x1. So x2 minus x1 is what? Again 0 here. Here it is 1. Then z2 minus z1 will be -2. Sorry, z2 minus z1 is of course 1 here. So we shall be getting 1. Next is x3 minus x1. That means here it is -3. Then after y3 minus y1 means it is 1. Then z3 minus z1, so it is of course -1. So this result will be equal to 0. Answer should come as 0. Then on simplification, what we shall get, of course we have to perform expansion, or directly also we can do by using properties. So if we proceed with expansion, it will be x minus 1. Then we shall be getting -1 -1. Then after this is minus y minus 1. Then after we shall be getting 0 plus 3. Then after plus z, we shall be getting 0 plus 3. That is equal to 0. On simplification, we shall be getting the result minus twice x, then minus twice x, then after minus thrice y plus 3z plus 2 plus 3 is equal to 0. So ultimately what answer we shall get? Twice x plus thrice y minus 3z is equal to 5. This is the required equation of the plane. Then coming to the next number, coming to question number 7. This is another important sum. Question number 7, what is given? Find the intercepts. Find the intercepts. Find the intercepts cut off by the plane, cut off by the plane. Twice x plus y minus z is equal to 5. So here in this case, what do we have to do? The intercept form of equation of a plane we know as x by a plus y by b plus z by c is equal to 1. So in this form we shall try to get this equation now. So given equation of the plane is twice x plus y minus z is equal to 5. So the best way to get this intercept form is what? Divide both the sides by the term present on the right hand side, that is by 5. So dividing both the sides by 5, we shall be getting what? 5. Here also it is 5. So we shall get twice x by 5, y by 5 minus z by 5 is equal to 1. So next let us check what we get. We have to make this term x independent of 2. Therefore this first term should be divided both numerator and denominator by 2. So this comes as 5 by 2. So the second term is fine, it should be as it is. Then plus should be put here, and this will come as minus 5, that is equal to 1. So which is the required intercept form? Hence the required intercepts are, in this case it is 5 by 2, that is the x-intercept, then y-intercept is 5 and z-intercept is minus 5. So this is the required answer for question number 7. Question number 9 and 10 are of the same kind. I shall be proceeding with question number 10 next. So question number 10 is here. What is given? Find the vector equation of the plane passing through the intersection of the planes vector r dot 2 I cap plus 2 j cap minus 3 k cap, that is equal to 7. Then after vector r dot 2 I cap plus 5 j cap plus 3 k cap, that is equal to 9, and through the point 2 1 3. So coming to its solution, what is given? We have to find out vector equation of the plane that passes through the intersection of planes this and this. Means these two planes, actually this plane and this plane are intersecting, and the vector equation of that plane which passes through the intersection of these two planes we need to find out. So coming to the solution part, the solution what is given, we have to write down here given equations of the plane as vector r dot 2 I cap plus 2 j cap minus 3 k cap is equal to 7, which can further be considered as vector r dot 2 I cap plus 2 j cap minus 3 k cap minus 7 is equal to 0. So this I can consider as 1. Similarly for the later part, and what else is given? Vector r dot 2 I cap plus 5 j cap plus 3 k cap is equal to 9. So from this we can write what? We can write vector r dot 2 I cap plus 5 j cap plus 3 k cap minus 9 is equal to 0. This should be the second equation. So for the equation of a plane passing through intersection of two planes can be given in this way. The equation of the plane passing through intersection of intersection of 1 and 2 is, how can we write it? There is a particular way of writing. That is what I'm going to place here. The first result means RHS of this part means vector r dot 2 I cap plus 2j cap minus 3k cap followed by minus 7 plus lambda. The second part I shall be writing vector r dot 2I cap plus 5j cap plus 3k cap minus 9 is equal to, what could be written? 0 could be written. Here in this case lambda belongs to the set of real numbers actually. So after this, what could be done? Again the plane passes through. Here I am going to mark this as 3. Again 3 passes through the point. One point is also mentioned in the question, and that is what? 2 1 3, 2 comma 1 comma 3. So that can be written here 2 comma 1 comma 3. So after this, what can be done? Its position vector can be written as, wait, position vector. What is the position vector here? Means vector r could be at this particular point, vector r could be 2I cap plus j cap plus 3k cap. This value should be put in 3. So we shall be getting what? In 3, some modifications we have to make now. That is what? Vector r dot 2I cap plus 2j cap minus 3k cap. They should be taken together. After that, plus lambda vector r dot 2I cap plus 5j cap plus 3k cap, that is equal to 9 lambda plus 7 should be carried to the opposite side. So here what could be done? R can be taken common. So after this I can write 2I cap plus 2j cap minus 3k cap. After that plus lambda 2I cap, this is nothing but simplification of equation 3, k cap, that is equal to 9 lambda plus 7. So after this we shall write, this substitution can be made 2I cap plus j cap plus 3k cap, 2I cap plus 2j cap, sorry, here it should be actually in combined form. We can write this in what way? Let us check. This I can be taken together, 2 lambda plus 2 I cap plus 5 lambda plus 2 j cap plus 3 lambda minus 3 k cap, that is equal to 9 lambda plus 7. So after this we can write 2 into 2, again once again dot product values we have to write here, plus 2 plus here 5 lambda plus 2, then after plus 3 into 3 lambda minus 3, that is equal to 9 lambda plus 7. On simplification I shall get here 4 lambda plus 5 lambda plus 9 lambda plus 4 plus 2 minus 9 is equal to 9 lambda plus 7. So on both sides 9 lambda got cancelled. So I get here 9 lambda is equal to, it should be minus 3, taking this to the opposite side, this is 10. So result of lambda will be 10 by 9. Result of lambda is 10 by 9. Now this value I have to put in equation 3 to get the entire result. Therefore equation 3 will imply what? Vector r. Actually in modified form I have to write it down. It will be vector r dot, within bracket it will be 2 into 10 by 9 plus 2 I cap plus 5 into 10 by 9 plus 2 j cap plus 3 into 10 by 9 minus 3 k cap bracket closed, that is equal to 9 into 10 by 9 plus 7. So while simplifying we should get the answer as the simplified form I am writing here. These are simple calculations. So this is 38 by 9 I cap plus I shall get here 68 by 9 j cap plus 3 by 9 k cap, that is equal to 17. So after this, vector r dot 38 I cap plus 68 j cap plus 3 k cap is equal to 153. So this is the required equation of the plane. Coming to question number 12. In question number 12, what is given? Find the angle between the planes. Find the angle between the planes whose vector equations are vector r dot 2 I cap plus 2 j cap minus 3 k cap is equal to 5, and vector r dot 3 I cap minus 3 j cap plus 5 k cap is equal to 3. So coming to the solution part, what do we have to do? From these equations we have to find out some results. Those are what? Let these be compared to given equations of the planes are vector r dot 2 I cap plus 2 j cap minus 3 k cap is equal to 5, and vector r dot 3 I cap minus 3 j cap plus 5 k cap is equal to 3. So from this we are going to assume, means first value, that is n1, vector n1, I am going to consider this as this whole thing as n1, and this as I am going to take as d1, this as n2, and this as d2. So what could be written here? Let vector n1 is equal to 2 I cap plus 2 j cap minus 3 k cap. Then n2, vector n2 is equal to 3 I cap minus 3 j cap plus 5 k cap. At the same time I can write here d1 to be 5, d2 to be 3. So here in this case, for finding out angle between the lines, angle between the planes, let theta be the angle between the planes. Then we can write what? Cos theta is equal to modulus of n1 dot n2, vector n1 dot n2 divided by modulus of n1 to modulus of n2. So the respective values I am going to find out now for both numerator and denominator. So 2 I cap plus 2 j cap minus 3 k cap dot 3 I cap minus 3 j cap plus 5 k cap divided by square root of, here in this part it is 4 plus 9, then for this part it is 9 plus 25. So what would I get? What I would be getting here, this is cos of theta modulus, this will be 6 minus 6, then minus 15. Then after, for this part, root 17. Then for this part, 25 plus 18, this will be 43. So ultimately we shall get theta is equal to cos inverse of 15 by root product of 17 and 43 will be 731. So this is the required answer. After this, coming to question number 14. In question number 14, to find out distance between a point and a plane. Question number 14, what is given here? In the following cases, find the distance of each of the given points from the corresponding given plane. So here 4 questions are there. I am picking up the second one, B. The point given is 3 minus 2 1, and the plane is twice x minus y plus 2z plus 3 equal to 0. So we already know that, actually one formula I must have to give here. If suppose any point is there, x1 y1 z1, from this point, if we are trying to find out distance of a plane, say ax plus by plus cz is equal to d. In that case, the distance could be written like this: capital AX1 plus capital BY1 plus capital CZ1 minus capital D divided by square root of A square plus B square plus C square. This is the way we can calculate it. Means the value of the point should be substituted here. So in our question, in the solution part, what is to be done? Given point is 3 minus 2 1, and the plane is we get a plane to be twice x minus y plus 2z plus 3 equal to 0. Therefore, the required distance is equal to modulus of twice 2 into 3 minus, in place of y we need to write minus 2, then after plus 2 into 1, then after plus 3 divided by square root of 2 square plus minus 1 square plus 2 square. So what answer could be obtained here? Let us see. Modulus of 6 plus 2 plus 2 plus 3 divided by square root of 4 plus 1 plus 4. So we shall be getting here the result as 13. Sorry, this should be extended. Result should be above, we shall be getting 13, and in the denominator part this should be 9. This will be ultimately root 9. So we shall be getting 13 by 3, and this is the answer. So the remaining sums of this number can be done in the same way. That's all. With this exercise gets over. Thank you.